Assalamualaikum and a very good day. My name is Hisyam and my matrices number is 87135. So I will present about my final year project for FIP1, which covers from chapter 1 until chapter 3. So my project title is Past, Portraits and Stories of Historical Figures through Augmented Technology on History Textbook. So without further ado, we start with chapter 1, Introduction. The 21st century educational landscape is being drastically transformed by digital technology with immersive tools like augmented reality, which offers students more creative and engaging ways to comprehend complex subjects. So, in the Malaysian context, history is often perceived as a demotivating and difficult subject due to the massive volume of factual data packed into one static textbook. So this is my kind of way to support the government's AI into Rakyat initiative, which aims to boost digital literacy for 1 million in Malaysia, which this final year project introduced PASS, an augmented reality application that scans specific textbook images. Students can access interactive 2D content and archival galleries, transforming passive reading into an active exploration of Sarawak local heritage. But these apps focus on historical figures specifically. So how can I come up with this project? We can see in the problem statement. First point is passive learning and low student engagement. A traditional approach of teaching history using rote memorization and static textbook-based instruction makes students difficult to stay interested in the subject. This leads to the disengagement which the subject lack of appealing visualization, causing it to be boring and bland, particularly for the digital native students. Which is why PASS offers an appealing visual and an interactive kind of way for the students to stay interested in the subject. Moving on to the second point, absence of augmented reality integration. Malaysia still have not implemented AR tools for their education system, particularly in these non-technical subjects such as history. So the modern technology is still limited with certain subjects only, such as science and language. The STEM subjects like that, which indeed prove can enhance the interest. Therefore, PASS is designed specifically as a learning tool for history subject that focus on a certain smaller areas first. Because I try to make it work first, because if I try to do a wider scope, it might be not perfect and ruin the project, which is why I try to small my scope first. So the primary aim of this project is to enhance the learning experience of Malaysian history, particularly topics related to Sarawak, and an AR mobile application that can serve as a supplementary educational tool for secondary students. The specific objectives are: 1. To develop a functional augmented reality mobile application that can recognize and track specific image targets from secondary school history textbook. 2. To integrate a visualized learning module focused on Sarawak history, featuring information cards, image galleries, and key facts. 3. To evaluate the application effectiveness as a teaching tool based on the feedback from the secondary school students and their educators. So these are the project scope. For the tools, I will develop the application using the Unity editor engine, and for the scripting, will be use C#, which integrate via Visual Studio. And the design, I try to design the application by using Canva or Figma, but mostly will be use Canva, I think, because Canva can generate image and Figma can make an UI UX experience, UI UX applications. So we will see how I do that later. The platform that the application will use is Android operating system. So my target audience is primarily for Form 3 and Form 4 secondary school students because in their textbook, in their history textbook, there's a Sarawak topic in them. So I want to do the Sarawak heritage for this application, which is why I focus on these two Form secondary school students first. For my secondary audience is the educators, of course, and the potential is person that are interested in Sarawak heritage. The content focus exclusively cover topics related to Sarawak history and historical figures, which is why I try to target my audience is from Form 3 and Form 4 secondary school students. So the assets will utilize 2D interactive assets and user interface elements. So this is the project schedule for my FYP1. This is by weeks. As you can see, how I submitted and completed my FYP1 by using this Gantt chart schedule. Project outcome, what can be expected, what can be expected to be delivered from this project. Validate application prototype, straight to the point, a functional PaaS application capable of accurately recognizing designated textbook image, and a created learning module covering at least 5 key Sarawak historical figures, and a comprehensive analysis of the app's effectiveness in enhancing student engagement. Let's move on with Chapter 2, Literature Review. These are the applications that I have reviewed and tried before. The first application are Dinosaur 4D+. It uses a physical flashcards deck to reveal a 3D model dinosaur. The cards actually need to be purchased to fully experience the apps, but I found the free demo cards from the Othman Studio website, which are the company that developed the apps. And these apps not just show a 3D model but also many other visualized elements like height comparison of the dinosaur and human, and then the geographical habitat of the dinosaur, which kinda interesting. And next, the 360 elements AR. Similar with the Dinosaur 4D+, the cards also need to be purchased before, but again, I found the demo from the 360ED official website, and it also prompt out the 3D model of the object or condition that is related to the elements. Also, a periodic table also appear alongside it. And next, the third application, which is the Ginkgo history. It is actually not an AR application, but a learning history one. So it's just basically a quiz type of general history, which users have to swipe to reveal the answer and navigate through the next questions. I choose these applications because it's related to history, so I might found something useful to be applied inside my proposed project later on. And then finally, the virtual reality history, as it names, it is in a virtual reality application which actually use VR goggles, but I only use my smartphone gyroscope. So if your phone does not have the gyroscope system, then they cannot experience the visual field trips to historical environment or locations itself. And yes, I also obtained the free demo from its official website, also which is Abacus brand, which give a sample of the book pages to scan it. And this aligns with my proposed project that use physical book to scan the target images, so I might use some similar layout from these apps but with a twist of AR touch, which is why this is an application that I choose to inspire my proposed project. For the comparison between the 4 applications that I review with my proposed project, which is PaaS, of course the focus subject are the Sarawak history, the technology, the augmented reality, the integration method. I want to use the existing school textbook, and the hardware required by only using smartphone, and the syllabus alignment must be the same with the Malaysia KSSM syllabus, And then the content style I want to use the 2D interactive cards, and the cost, there are no other costs for this uh, application, which is free and open access by using only smartphone. So for the technical specification comparison for my project pass, it will use camera as its primary input, and then will be fully offline so that user can easily access it. And then I approximately the storage size around 200 MB if I can manage it. And then the device tier is of course entry level so that many students can easily use uh, the low entry device to access and download this application. So let's head into the chapter 3 methodology. So for my methodology, I use the module Rapid Application Development, in the short form is RAD. And in the analysis and quick design of the RAD, already established the logical structure of the application by designing the system architecture by utilizing the UML diagrams, which I will later explain about it. And then I conceptualize the visual interface by using Figma. This is only user interface mockups only, so it's not the final product. But later I might using Canva for the actual development of the user interface. But that will be explored by myself later. And then I already conduct a quantitative analysis by using jot form, which I share with my friends who has siblings and the little cousins, which are around from Form 3 and Form 4 students. And then I finalize this specific functional and non-functional requirements based on the experimental jot form survey. Next, for the prototype cycles, it has built, demonstrate, and refine. Basically, I just try to achieve my goals, which is to ensure that the camera can accurately follow the textbook images and display the output of the 2D historical data. And if it's not appear or it's not working, then I will refine it again. Basically, it is a loop until I manage to get the right and achieve my main goals. So that is basically for the prototype cycles. So moving on to the testing phase, the target audience, which consists of educators and Form 3 and Form 4 students, they will participate in the usability testing. And this phase evaluates the application overall effectiveness as a teaching tool, and then how the user experience, also the technical performance to ensure that it satisfies all the project requirements based on the tester feedback. So the implementation in the final phase, the application is optimized and adjusts in response from the feedback of the user, as I said before, and the data collected during the testing phase. And finally, I will compile the final thesis report and documenting the complete development process. The phase brings the project to an end, and the final outcome, which I will present it in the project symposium later in FYP2. So for the system designs, as I mentioned before, I utilize UML diagrams to explain how my proposed applications will fully operate. And this is the first diagram that shows how, which is the activity diagram. User begins at the main menu, choosing either start a new AR camera scan or check their progress gallery. Before scanning, an instructions panel will pop up to the user to ensure the user is ready to use the applications. And if the user is ready, they can click proceed to initialize the AR camera. The system captures and processes the visual data from the textbook image target, and if the recognition is successful, it will trigger a simultaneously rendering of the 2D AR info cards and updates the figure as found in the progress tracker. And the learners engage with content by reading biographies while listening to audio narration simultaneously. The audio narrations I plan to make it controllable. So user can click either if they want to listen on the audio narrations or not. If they do not want to listen, then they can click to stop the audio narrations. Moving on to the next diagram, the use case diagram. The primary actor, of course, the student itself, as the main user who initializes the system directions. The system capabilities. The application consists of 7 distinct use cases. Launch applications, view instructions, scan textbook image, which is include with the view instructions, and then view AR content, play audio narration, view progress tracker, and view image gallery. This might be in the same interface, the view image gallery and the view progress tracker, which later will be cooperate with each other. And then the structural relationship, and it include, like I said before, dependency is between the view instructions and scan textbook image. The functional goal, this relationship ensures that methodical guidance is always provided as an essential part of the scanning workflow. So the third diagram is the sequence diagram. The sequence diagram, actually I have two, which showcase a scenario A and scenario B. Scenario A is about the AR camera and the scenario B is about the progress gallery. So I explain about the scenario A first. The process begins when the student taps Start prompting from the main menu to activate the instruction panel, and if the user ready, the user can click proceed on the instruction panel, which it will initialize the AR camera controller. When a valid textbook image is recognized, the AR camera controller notifies the content manager, and it sends an unlock figure signal to the progress manager while producing the 2D info cards and audio assets. The progress manager updates the local database as the AR camera displays the interactive content to the student. And then these are the second scenario B, which is about the progress gallery. It's triggered when the student taps the progress gallery button on the screen, and the main menu UI requests the list of unlocked figures from the progress manager. The progress manager fetches the relevant data from local storage and returns the list of discovered figures back to the UI. Once received, the main menu UI populates the screen with the unlocked assets and display the final gallery to the students. This streamlines the interactions, ensures that all user achievements are accurately reflected using locally stored data. Why I want to include the progress gallery? Because the progress gallery is the gamifications of the project. It's an gamifications elements that might make the user interested and motivate to unlock the historical figures of the Sarawak heritage, the Sarawak one, which is why I want to include the progress gallery. So yeah, let's move on with the fourth diagram, the class diagram. The class diagram, the main menu script serves as the central interface, managing core navigation through instruction controller, progress manager, and gallery UI. The AR tracker event handler manages image recognition via target stats, while content loader handles the presentation of history data, including UI overlays and audio. The progress manager tracks persistent data, such as the list of unlocked figures, and provides essential functions for saving and loading user progress. Dependency and association links between the progress manager and other components ensure that the application state remains synchronized as students discover new figures. So this is the class diagram data. It's not that much have a database, but it has a simple local database for store the image, and if the user finally tracks tracks the image, then we unlock the progress for the user. These are the mockup interface which I designed using Figma. The first image is the main menu, which have the application title, the two buttons, Start AR Camera, and the Progress Gallery. If the user click the Start AR camera, it will pop up the instruction panel that shows the user how to operate the AR camera. And if the user ready to use it, they can press the Tap Proceed button to find and scan the target image. It might show an animation later if I manage to insert it about the scanning image. Then the info card will be prompt about the historical figures. Also, there is an audio narration button on the info card for user have control over it. Then finally, the progress gallery interface. I will try my best to achieve similarity with this interface, but as I said before, this is just a mock-up design, therefore the final outcomes might differ from this. So these are the requirement analysis that I have distributed to the secondary school students and among my friends. Uh, the data collected are from 45 respondents, of course, from the Form 3 and Form 4 secondary students, and also from their parents, and maybe from the educators because there are comments about how the applications works and how it's supposed to works, and then also from my friends also that help to fill out the form. What I have gathered from this, I use a short form survey to collect data, and the data confirms that is important for a new approach to the history educations, which we can see in this chart. This chart is about student learning challenges. You can see 75% of the students struggle to memorize the facts from the text, which is indeed true. And then 73% find it hard to visualize the static photos, which is only bland and not interesting. It's sometimes in black and white color, and there's no this make user feel less interested, and 70s and 67s admit to feeling bored during their traditional lessons. So this is the pie chart for the operating system distribution, and as we can see, many of the users are using Android devices. So for the key future demands, many students have high expectation for the futures of this application. Actually, this I will cover later in the functional requirement. So that is all for the requirement analysis. So these are the functional requirements, which has 5 key features that I have analysis and gathered from the jot form survey before. The image recognition and tracking. Of course, the system need to accurately recognize the historical figures using the Form 3 and Form 4 history textbook. And of course, it need to use the device camera. And this requirement is supported by 78% of the survey students. And they also wanted and demand that the image need to be realistic as it can. So instead of cartoonish historical figures, I might need to work more to find a realistic image for the historical figure. And then the 2D content overlay, upon successfully tracking, of course, the interactive materials need to be displayed over the physical textbook. And these assets include interactive timelines, image galleries, and summarized info cards, satisfying their preference for visual learning over plain text. Like I said before, I might try to make the application as visualized as ever, but what I think I'm capable of is create a plain text factual informations like my design before. Yeah, I think I'm capable of doing that, but I will try to make it as visualized as it can, so it can make the user interested with the applications. And then the audio narration and control, which assists auditory learners with pronunciation and understandings. This already has in my plan that I might use 11 labs for the voiceover narrations of the biographies. And of course, this feature also includes the play and pause controls, is also requested by 40% of the respondents for personalized space, which kind of important because not every student has the same pace. They have their own pace. So then, if they do not want to rush the learning process, they can pause the audio narrations. And also, if they do not want to hear the voice narration, they can just read only. And then the gamified progress tracker, like I have mentioned many times before, a tracking future monitors that the historical figures after the students successfully scan the historical figures, it will unlock inside the gallery, which makes the student feel like history is more engaging and fun rather than the traditional reading methods. This is my gamifications of the applications. And then last but not least, the offline accessibility. The application must function without an active internet connection after the initial download, which is a critical technical requirement to ensure that students can access the the applications anywhere. I list out the non-functional requirements inside this table. As can be seen, the compatibility. The app is developed for Android 8.0 version and above to ensure inclusivity, as 67 of the target audience utilize Android devices. The storage efficiencies. The total size is optimized to stay under 200 MB, as 42% of the student will not download apps exceeding 400 MB. This is all depends on the final result of the development of the applications. Maybe if there are more visualized elements inside the applications, and then it might exceed the 200 MB. So that's I cannot promise if I can achieve it or not. And then the hardware independence. The system relies solely on the standard camera. Of course, the standard camera is the essential key for the application. The performance. The content is designed to load within 3 seconds of detecting a marker. This is achieved by using optimized 2D assets instead of high polygon 3D models. This is why I want to make a 2D content info cards also, because I want to make the experience of the applications as smooth as possible by loading a simple image to the assets, a simple 2D assets instead of the 3D models. The 3D models might be delayed, as I have tried also before from my game development project. The 3D models is indeed delayed, and the 2D assets is much faster. Usability. The interface is built for non-technical users, featuring clear prompts and experience buttons. Like this is for the navigation one. The user might be not familiar with the application, so I try to create a next or previous buttons instead of swipe like the Gingo history. When I first using it, I don't know how to operate or navigate the applications. When I try to play around, you swipe to the next page, and this is might be handful for the user to understand better on the applications, which is the next and previous buttons. This is also validated by the respondents who prefer button navigation over traditional scrolling. To conclude my FYP1, the past application established foundation given the first 3 chapters of this project, which highlight the critical requirement on why augmented reality can be interesting to use. Instead of only focusing on STEM subject, we should give opportunity to explore using AR on other subject also. My research has already been elaborated from the functional and non-functional requirement parts before. Therefore, to address these gaps, the requirement analysis from the 45 respondents has proved that they are interested with these applications. So yeah, by utilizing RAD model, I will try my best to complete this project later in FYP2. So that is all for me. Thank you very much and see you in FYP2.